Just be clear about our schedule moving forward. Today is Wednesday, then we have Thursday, Friday, Saturday, Sunday. And we have Monday, Tuesday, Wednesday, Thursday, and Friday next week. Today we're covering this, which is in our section 6.1. Tomorrow we are going to spend Thursday and Friday covering a single lesson. It's a little bit more complicated. Today's pretty easy. You got a day off here on a weekend. You got Martin Luther King Jr. Day. And then we're going to come back on this Tuesday and we're going to cover SOHCAHTOA, solving right triangles. And then you have a work day in your study guide on Thursday, and then we'll test next week Friday. That's our schedule right now where we're at. So I'll try to get that study guide to you actually on Friday before you head on home for the weekend and go from there. So arc length and area sector. We talk about a circle, and within that circle I want you to draw an angle that we will call theta. An angle that we call theta. And we have a radius. And the arc length is referencing this thing right here. And we're going to use the variable s to represent that length of that arc. Okay, just like to use s. Going to dig back to your geometry days. Who remembers the formula for arc length in geometry? We'll start easier. Who remembers the formula for circumference of a circle?
Pi times diameter.
Pi times diameter, otherwise known as 2 pi r. So we have and by the way, this is kind of, people wonder kind of what do they want to know, what do they not. So 2 pi r for a circumference, that's not something you'll get on the ACT. Those are ones that they'll expect you to remember. We'll do a full review of that stuff, but that's something you want to lock into memory eventually. But that would be the entire distance around, and we don't have the entire distance, do we? We just have part of it. So we just have a fraction of that. So we multiply it by the fraction, which is theta over 360. And that's your formula for arc length. That's if you're working in degrees. But the fact is we don't have to work in degrees. We can work in radians. And radians can be very useful to us. For example, if I rewrite this as 2 pi times r, and I multiply by theta divided by, if I'm working in radians, instead of 360, I would have 2 pi. Okay? Notice that when you multiply these, what happens? The 2 pi's reduce, don't they? And you just end up with the equation of s is equal to the radius times theta, where theta is in radians. So if you're in degrees, use that. If you're in radians, you use that. Much smaller formula, isn't it? So if we go to example number 7, we'll look at that. It says find the length of an arc on a circle that has a radius of 24, and the arc subtends an angle of 60 degrees. So subtends just means that it spans the angle of 60 degrees. So we're just looking for the red distance. And the red distance is arc length. So S is r theta. What is the radius in this problem?
24.
24. And what is the angle?
60.
The angle is 60 if we're working in degrees.
Pi over 3.
But in radians, the conversion pi over 3. So if you type in 60, you're not going to get the right answer. You type in pi over 3, you're going to get the right answer. And you end up with 8 pi. This is the exact value in terms of pi. You would like to be able to express it both as an exact value and as well as an estimate of a decimal. So if I go to my calculator and I type in 8 pi, I get 25.13. So on your assignment, you're asked a couple times to express it exact in terms of pi, and there's sometimes you're asked to express it as a decimal, so 25.1 here. Everyone okay with that first example? We just have one more, you'll be able to work on your assignment. The next one, we're looking at area of a sector. So area, we're going to use the variable k to represent area. And area is that space. Okay, so all that stuff. So now I'm drawn to a different formula. Instead of circumference being 2 pi r, I'm drawn to the formula for area. What's the area of the circle? Pi r squared. That is another one that you will not be given that you want to make sure that you know. And again, we just have a fraction of it. We just have theta over 360. And that will produce the area for us. That's if you're working in degrees. I don't want to work in degrees, I want to work in radians. So what am I going to change?
360.
Good. 360 changes from 360 to 2 pi. As you make that conversion, you can see that the pi's cancel. The 2 does not cancel. So you're left with area, k, is equal to a 1/2 times r squared times theta. Area is 1/2 r squared theta. That's your formula if you're working in radians. I give those formulas to you on the test, but you need to remember how to use them. We move to example 8. It says find the area of a sector of a circle with the radius of 12 and a central angle of pi over 3. This is pretty straightforward. We have area k is equal to 1/2 r squared theta. I plug in 12 for r, and theta is already in radians. So I don't need to change it from pi over 3. It is just pi over 3. K is equal to 1/2 times 144 times pi over 3. We multiply by stuff in the numerator, we divide by stuff in the denominator. You can see this is 144 pi over 6. It does turn out that 144 is divisible by 6. We get 24 pi. That is the exact value. If it says it would like it expressed as a decimal, then you can go ahead and just on your calculator, you can go 24 pi and you get 75.4. And that's your approximate value. And that's it. So open up your homework.
What were these?
We can do it. Not important. If I had more time, I would go back and kind of review some of the examples and get rid of stuff and add stuff. We want to save our time for chapter 7. That's where things get tough. So you're going to open up the section that Haley's on right now. And notice on this section that looks like this. It says find the length of each arc. So there you're using your arc length formula, which is S is equal to R theta. On the top, it says round to the nearest tenth. For the second set of your assignment, it says find the length of each arc, don't round. So for the bottom part, you're going to write it in terms of pi. As you flip over the other side, so the front side is all on arc length. The back side switches to using area. So obviously the formula for the area, you're gonna use 1/2 r squared theta. The top, round to the nearest tenth. The bottom says do not round. You can write it as in terms of pi. The answer key is on the board. It is my hope to get the answer keys posted online today. I just can't seem to get my prep, so just gotta, somebody else is gone 8th hour, so I'm gonna sub next hour. Maybe I'll bring them in here so I can work in here. What do you think, Maggie? Think they'll cooperate? They're 8th graders.
Yeah.
Any advice for me on working with the 8th graders? What if they call me dumb?
Calm down back.
What if they raise their hand and they say, Mr. Gans, did you know that you're bald?
And say, do you know that you're bald?
I like it. Those are good comebacks.